Okay, so let's begin. So, what is clustering? So, when we are dealing with clustering, we work with data that has no labels. And what do we mean by data that has no labels? So, let's say, for example, you are being admitted in a school. So, we have your results, we have your history, and we can't prove that you are a genius or not, or maybe we can say that this guy is intelligent or not. So what we can do is we can use that data and we can group you into the different categories that you have. So for example, for let's say we are working at Safaricom and we want to know if the service that we are using has a downtime or not. So the thing is, with the data that is coming in from Safaricom, we can't directly say that there is a downtime based on what you are saying, but the data itself will tell you if you have a downtime or not, because what you will have is different from the norm. So clustering is mainly used for anomaly detection. So let's see what anomaly detection is. So here you can see what anomaly detection is. So we have values that are moving in within a range, but at a given point, the value goes up more than expected. So that's what anomaly detection is. And the aim of clustering is to come up with labels that can allow you to like say this event belongs to this group. Okay. So that's what clustering does. But with examples, so with practical examples, you'll get to know what it does. So today we are going to look at one of the models that we can use, and that is the K-means clustering model. So K-means is a popular clustering algorithm used to classify a given set of n-dimensional points into K clusters. The algorithm is based on the concept of minimizing the sum of squared distances between each point. So you can see it's based on distance. And here we are looking at a plot that is distance based. Okay. So how do you create your clusters? So these are the steps. So you initialize the K centroid randomly, assign each point to the closest centroid. So I would have explained this using a diagram so we can get one. So I'll search for K-means, then you can have a look at this. So here we have an unlabeled data set. Then we try label that data set where we are trying to create a centroid. I guess I have a presentation on this, but I'll share that later. So let's skip the theory part and look at this practical part. So how do you come up with your K-means? So I'll open my VS Code and we are going to work on the practical part. So we will use the iris dataset, and using the iris dataset, we are going to see if the K-means model is able to come up with labels that are similar to what we have in the K-means dataset. And what we will use to like compare this is the original target variable. So I'll create a new notebook called kmeans.ipynb. And let me zoom in so that you guys can see what I'm doing. Okay, so let's start. So this will be the K-means, and I'm going to copy some codes from the notes. So these will be used as our outline. So I'm going to copy that, then I'm going to paste it there. And then from our class, I believe we've discussed something on the iris dataset. So I don't know if we used logistic regression or which model we used.
I think we used logistic.
Okay, I'm trying to check and see. Yep, so we used KNN. So KNN is similar to K-means. So this is just the part that we have up here is just for reference. Okay, so let's begin. So here we are importing our iris dataset. So we will have from sklearn.datasets import.
Joseph,
Yes.
kindly zoom in.
Okay, sorry, I forgot to zoom in. Okay, so that's it. So this is from the KNN notebook. So we have iris being equal to load underscore iris, that is from sklearn. Then we create our data frame and we extract our. So here we have our target, but it's not a must we add the target in this new data set. So let's run it. So what we want to do is we want to feed a K-means model that will recreate our target column for us. So instead of us knowing what should be in the target column, we want the model itself to learn and recreate the target column for us. Okay, so I'm loading the data, so let's give it a minute to see what will happen. Let me reload my notebook, then we can proceed. Okay, so everything should be fine now. I was getting these red lines. So we can run that, then we can check our iris.head. So the main aim in these models, so the K-means clustering, is to recreate the labels stroke targets. So first of all, we will decide how many target variables we want, and yeah. Okay, so I see an error somewhere, so import pandas as PD. Yeah, then we can run that again. Sorry, I never saw that part of importing libraries, so we missed that. So let's start this again by importing our libraries. Okay, so I'm getting an error, I don't know why. So a minute, I check my notebook. I don't know what's going on. Let me close this completely, then reopen it. Okay, so it should work now. Yep, so this is our data. So if we check the target column, that's what we need to ignore. So for K-means, we will go directly to the point. So when creating your K-means model, so what you have to do is specify this part here, the number of clusters, which is n underscore clusters. So the n underscore clusters, so here you can see we have a few things that I have explained. The n underscore clusters defines the number of targets you want your dataset to have. So if we run something like irisdf dot, then we select the target column, then we do the value count. You can see we have 3 targets, and these are the 3 targets that we want to have. And another thing we can do is we can visualize the data using a scatter plot with the color representing the target. So here we can have sns.scatter, then we can take 2 variables. So for me, I can pick the petal length and the petal width, then we can have the hue as the target, so that we can see how this data looks like with the original target. So this is what we have. Okay, so what we want to do is we want to recreate these targets based on a model that we are going to use, or a model that we are going to recreate. So first of all, we need to import K-means. So we will have this. So from sklearn.cluster import K-means. Then we are going to instantiate our K-means model with 3 clusters. So these 3 clusters here, so this is a hyperparameter. So we will have K-means being equals to K-means, then n underscore clusters being equals to 3. So remember, just like we did here in the KNN model, where we were specifying the number of neighbors. So for K-means, we also have to specify the number of clusters. After doing that, we fit the model to our data. So what we will do here is we will have our x only. So I'm going to say x, let our x be equal to iris.drop, then we drop our target. So we are not going to create any y value, so just the x value. So we are going to have our k-means dot fit, then we fit the x. Then our y will be equal to k-means dot labels. So note here, we are not typing in. So get the assigned labels. So note here, we are not getting the predicted values, but we are getting the assigned labels. So our y will be equal to the assigned labels. Then we can run that. And then what we can do is we can repeat this. So instead of, what we can do is we can say, let our iris df k-means. So here we can say k-means target be equal to y. Then we can see the data head. So iris df dot head, see the new added column. So here we have the k-means target. So you can see the values in the k-means target are somehow close to the original target column. Then what we can do is we can now visualize this plot again. And instead of using target, we are going to use the k-means underscore target. And if we run that, you can see this plot that is here. So let me create a side-by-side view. Okay, so we have this second plot, and our first plot is up here. Do you see some similarities? Even though some of the labels, so for example, for this part here, where my mouse is, even though some of the labels are not similar to what we have on this other side, we have the targets 0, 1, and 2, which are somehow close to what we have over here. And basically, that's the use of the K-means and the clustering models. So, do you understand how the clustering models work? We can research more. And for today, I
No,
want to,
yes,
yes,
yes. Just
yes,
I would like us to check on the where on the code. There's
yes,
a
yes,
point I was actually trying to internalize,
yep,
and let's just go back to the code.
this part,
And yes, exactly.
yeah,
But I wanted to understand these labels,
yes,
the labels that we are having.
yes,
Remember, in supervised,
yes,
we are always trying to, you know,
predict,
the x-axis is having the variables, right?
yes,
If I'm not wrong, and
yeah,
then the y-axis the target,
yeah,
and then in this case it is, I don't know whether it's the opposite, because for the y for the y we are having the k-means dot labels.
yes,
So are these labels the central points for the clusters?
no,
That is the question. That's the first question.
no, these are not the
Because we
central
are
points.
clustering.
So
Sorry.
we can add, so these are not the central points for the clusters. These are the actual labels that have been assigned to specific data points. So if we want to get the centers,
Yes.
you can get the centers by typing in k-means dot clusters underscore centers. So you will get the cluster centers. And actually what we can do is we can visualize the data with the cluster centers. So here you'll see the scatter plot. Then we will add the centers to that data. So using plt.scatter, then we pick values from the cluster centers. So let's run this and see what we get. So you can see the centers here in black. So the centers define like
Great.
the kind of label we will assign to that class.
Okay, I
Yeah.
got you.
And from the nodes,
Joseph, sorry. So
yes, yes.
what are the labels? Yeah, now I'm confused.
What are they?
Labels, what do they represent now? The
Okay,
labels.
a minute, let me get my pen. Then I can explain to you better. Okay, so here we are. Let's say we have this data set here in that box. So this is our, let's say, number one. And let's say we want our output to be here. This is our endpoint. So this should be number two. In box number one, we have this part here, which has some excess. We have this part up here, which has some zeros. Okay. So for the K-means model, what we are trying to do is in box number one, we have no labels, right? So let's say someone is visiting the forest and this is what he saw in box number one. So what this guy will do is he will observe what is in the forest and he will say that where we have the excess here, we can maybe put in a center there and say that anything that is close to this center will be an X. So values that will be here, 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 here will be of class X. Then again, he will go further deeper into the forest and he will see this part here where we have some zeros. Then he will create another pole center here. And he will say that anything that is close to this center will be a 0. But the challenge is, how will you explain these zeros and x's to someone else who hasn't been into the forest? So what he will do is he will come up with another map where we have the x's. So let's say the x's are here, right? And up here we have our zeros. So instead of calling these x's, he will assign to them a label. Maybe let's say trees. So these are trees. And up here, instead of calling these things zeros, he will say, let this be potatoes. And basically that's what the K-means model is doing. So instead of like you having to like go through your data and seeing all these. So what the K-means model does is, let me scroll down. I don't know if I'll be able to. I can create a new page. So what the K-means is trying to do is, if we have box number 1 here, and box number 1 has zeros, x's, and let's say y's, what the K-mean model will do is, first of all, it will go through the data, and inside this part, it will circle those zeros. It will come again and circle these x's. Then it will go again and it will circle those y's. Then after doing that circling, it will come up with labels for each. So for this first circle here, it will say, let this be class 0. For this second circle here, let this be class 1. And for the last circle here, let it be class number 2. So that if you go back to what you had, so anything that will be located at this region will be plus 0. Anything that will be located on the x's part will be plus 1. And anything that will be on the y part will be plus 2. So do you get what the K-means model is trying to do? Like, you don't know what is here, but at the end you will know. We have these 3 different classes that we need. Yes.
Okay. So that defines now the labels.
Yeah, that defines now the labels.
So label is the 0, 1, 2.
Yeah, label is the 0,
Okay.
1, 2.
Okay.
Yeah. And this is defined by the number of clusters. So for example, let's go back to our code. So if I said like, let there be 5 clusters, then we will have 5 different labels. So if I run this model again, let's see what we will get. So here you can see we have 5 different centers. So center number 1, center number 2, number 3, number 4, number 5. So we have 5 different groups. Okay. And if we say like, let there be 2 classes. So if I specified that we should have 2 classes, you can see, first of all, this group that is down here, where we have point number 1 in the y-axis to 2, then point 0 to 0 0.5, this will be class number 1, and from point 3, 1 to 7 2.5, that will be class number 2. So let's run that and see. So we will have two distinct colors if we specify our clusters to be equal to 2. So if I run that again, you see we have this class that is down here. So it creates a circle. So any value that is close to these values down here will be class blue, and any values that are up here close to this center will be class 1. So do you understand how clustering works? So it's all about creating labels to your data. So these labels won't make sense, but at times they do make sense. And I guess maybe a practical example will make better sense. So, and I won't do that maybe practically today, but I'm going to give you a scenario where this can be applied. So,
Joseph,
yes,
before you leave the application, I wanted to understand.
yeah,
Assuming now on the plot,
yes,
yes, don't move that from the
yes,
blue
mm-hmm,
all across. Like we have the white space there, right?
yes,
Yeah, you see the white space,
mm-hmm,
and we have the two blues plus the oranges. If I'm not yellows or oranges, I don't know. So assuming that we had like that space is fully occupied with the dots or the cluster, like it's clustered all through upper,
yeah,
and maybe you are trying to create a model and you
yes.
also want to come up with labels. Does it mean that it will be advisable for you to create more labels than maybe two or even three to make sure that it covers all that space,
Yes.
something that is near, and depending on the on exactly what you want to achieve? Or does it mean that there is a specific number of labels that you need to have?
Okay. I will say in some situations there will be specific number of labels that you will be required to have. So for example, so this is the example I was to tell you. So let's say you are working in Safaricom, okay? And you want to predict some fraudulent events, right? So if you were to create labels, so how many labels will you create? So for me, I will say two. So it's either an event is a fraud or it's a non-fraudulent activity. Okay. So this means that with the Safaricom data, so M-Pesa transactions, so let's say if you have the M-Pesa transactions, so from the M-Pesa data, you will be able to come up with labels as to whether that transaction is fraud or not, depending on the kind of transactions that this guy is doing. And we can try Google and see if we can get an example. So fraud detection using clustering. Okay. Yeah, so you can see this is there have been scholarly articles based on that. So you can maybe go through them and see how they are applied. So for example, we have application of clustering methods. Okay, let's see this in full. Application of clustering methods to health insurance fraud detection. So you can see things like that. So you will have to research more and get maybe data sets that you can work with. And maybe you can see, like, if you go through these research papers, you will get to see the thought process of these individuals. Okay. So that's one of the applications of clustering. Then another thing is, let's see some of the applications of clustering. Okay, so I want to show you something. So how many of you have ever used ChatGPT? So if you want to like get the info you want first, you should try this. So for example, if I say something like, where can I apply clustering in machine learning? I'm going to get some answers to that, and let's see what we get. So you can see clustering is an unsupervised learning. So the first one is customer segmentation. So if you are working in a supermarket, what will you say? So you will analyze that supermarket data and say that someone who buys these items is a high class earner, someone who buys these items is a middle class earner, and someone who buys these items is a low class earner. So that, let's say, for example, you are coming up with a fair promotion. You are coming up with a fair promotion. So if someone bought something like perfumes, so it means that guy has some disposable income that he can be able to like spend it on. Apart from the basic needs, he can be able to like purchase other things. But if someone usually comes in and buys only essentials, so let's say that's only food, so you will say that this guy is a low income earner, but this guy is a high income earner. So if you are to come up with a fair promotion that that's going to be used to like reward your customers, you need to come up with a way in which you can reward this guy who usually buys only food, and a way in which you can reward also this guy who includes other expensive stuff. So you cannot just reward each individual based on their spending. So you need to group them and say that this is someone who usually spends less money. So this guy needs a fair chance of winning our promotion. But this guy spends a lot of money and the chances of him winning are high. But we need to also have consider that. So maybe you can split the prices and say that guys that are in this trench of like maybe purchasing high value items can have 50% of the prices. Then these ones that are in this lower trench can have 50% of the remaining prices. So meaning that you will come up with a fair rewarding system instead of like saying that both these guys are equal, while you know that's not the case. Yeah, so that's just an example. And here you can see some of the applications of super unsupervised learning. Yep. So you can try use ChatGPT to assist you in your learning. So you can use it as your personal tutor. Because if I say something like generate KMeans code to cluster and visualize the iris dataset, it's going to generate some Python code for me. And that Python code will be same as to what we have here in class. Okay, so this is one of the things I would wish you guys to use in bettering yourself. So instead of just using what I've shown you in class, try use some of the AI applications that are available online to better your skills. So I can copy that code and I can paste it here, and will see if we get the same results. Yep, so here you can see what we are having. So it's not that accurate, but you can see the clusters are accurate. But I guess it's the centroids are up here because the centroids are, so it has applied something known as PCA. But remember, we haven't covered the PCA part. But yeah, once we cover PCA, you'll be able to understand that. So this was just a by the way, so showing you some of the extra resources you can use to upskill yourself. Yep, any questions? I guess I'll stop the recording there.